Lesson: Introduction to Natural Language Processing Concepts. Natural language processing is a fascinating intersection of computer science, artificial intelligence, and linguistics aimed at enabling computers to understand, interpret, and respond to human language in a meaningful way. As the demand for intelligent systems grows, so does the importance of NLP in creating solutions that can handle the vast complexity of human language. A comprehensive understanding of NLP is crucial for professionals aiming to excel as certified AI workflow and automation specialists, as it equips them with the tools necessary to develop applications that can process and analyze language data efficiently. At the heart of NLP is the challenge of understanding the nuances of human language, which includes not just syntax and grammar, but also semantics and context. The complexity of this task makes NLP a compelling field of study, as it requires a combination of rule-based and machine learning approaches to achieve meaningful results. One fundamental concept in NLP is tokenization, which involves breaking down text into manageable pieces, or tokens. This process is essential for further analysis and is the first step in many NLP applications. For example, in sentiment analysis, tokenization helps isolate words or phrases that convey emotions, enabling the system to understand whether a piece of text is positive, negative, or neutral. Practical tools like the Natural Language Toolkit in Python provide functionalities for tokenization, allowing professionals to pre-process text efficiently. Once tokenization is complete, the next step often involves stemming and lemmatization. These processes reduce words to their base or root form, making it easier to analyze text by minimizing the complexity introduced by different word forms. Stemming uses algorithms like Porter's algorithm to strip suffixes and prefixes from words, while lemmatization goes a step further by considering the context and reducing words to their dictionary form. For instance, the words running and ran are both reduced to the lemma run, facilitating more precise analysis. Implementing stemming and lemmatization can be efficiently done using libraries such as NLTK or spaCy, which provide robust tools for text normalization. One of the core challenges in NLP is understanding context, which is where part-of-speech tagging comes into play. POS tagging assigns parts of speech to each word, such as nouns, verbs, adjectives, etc., based on its context within a sentence. This process is crucial for tasks like syntactic parsing and semantic analysis, as it provides insight into the structure of sentences. For example, the word bank can refer to a financial institution or the side of a river, and POS tagging helps determine the intended meaning by analyzing the surrounding words. Tools like spaCy offer sophisticated POS tagging capabilities, helping professionals build systems that can discern meaning more accurately. With the advent of deep learning, NLP has witnessed significant advancements, particularly in the realm of word embeddings. Word embeddings are dense vector representations of words that capture semantic relationships by placing similar words closer in a multidimensional space. Models like Word2Vec and Glove have revolutionized NLP by enabling machines to understand and infer meaning from context. These embeddings are foundational for more complex tasks, such as machine translation and named entity recognition. For instance, in a task like translating text from English to French, embeddings help the model grasp the nuances of both languages, facilitating more accurate translations. Implementing word embeddings can be done using libraries like Gensim and TensorFlow, which offer pre-trained models and tools for training custom embeddings. Sentiment analysis is a practical application of NLP that involves determining the sentiment or emotional tone behind a piece of text. This application is particularly valuable for businesses looking to analyze customer feedback or social media interactions. By leveraging machine learning models trained on labeled datasets, sentiment analysis systems can classify text as positive, negative, or neutral. For example, a company might use sentiment analysis to gauge public reaction to a new product launch by analyzing tweets and reviews. Tools like TextBlob and Vader provide pre-built sentiment analysis capabilities, offering professionals a straightforward way to incorporate sentiment analysis into their workflows. As NLP continues to evolve, transformer models like BERT have emerged as state-of-the-art solutions for many NLP tasks. BERT's ability to capture context from both directions in a sentence allows it to achieve unprecedented accuracy in tasks like question answering and language inference. For instance, BERT can be fine-tuned to understand and answer complex questions by considering the entire context of a document, making it a powerful tool for building intelligent systems. Implementing BERT and other transformer models can be done using the Hugging Face Transformers library, which provides access to pre-trained models and tools for fine-tuning on specific tasks. In real-world applications, NLP faces challenges such as handling ambiguity, understanding sarcasm, and processing multilingual data. Addressing these challenges requires a combination of robust algorithms and domain-specific knowledge. For instance, sarcasm detection remains a difficult problem due to its reliance on tone and context, which are often absent in text. However, advances in sentiment analysis and contextual embeddings are helping overcome these obstacles by providing deeper insights into the subtleties of language. Similarly, multilingual NLP systems are becoming more proficient as models are trained on diverse datasets, enabling them to process text in multiple languages with greater accuracy. Evaluating the performance of NLP models is critical for ensuring their effectiveness in practical applications. Metrics such as precision, recall, and F1 score provide insights into a model's accuracy in tasks like classification and entity recognition. For example, in a sentiment analysis model, precision measures the proportion of positive predictions that are actually positive, while recall measures the proportion of actual positive cases that were correctly predicted. These metrics help professionals fine-tune their models, ensuring they meet the desired performance standards. Additionally, tools like confusion matrices and cross-validation offer further means of assessing model performance, guiding iterative improvements. In conclusion, mastering the fundamentals of NLP is essential for professionals seeking to excel in AI-driven roles. By understanding and implementing core concepts such as tokenization, stemming, and context analysis, practitioners can build systems that interpret and respond to human language effectively. The integration of advanced techniques, such as word embeddings and transformer models, further enhances the capability to tackle complex NLP tasks, from sentiment analysis to machine translation. As the field continues to evolve, staying informed about the latest developments and leveraging cutting-edge tools will enable professionals to address real-world challenges and drive innovation in their respective domains.